Welcome. In this video, we'll be talking about ACID properties of databases. So what is the ACID properties? Well, it's an acronym. A stands for atomic, C stands for consistent, I stands for isolated, and D stands for durable. The ACID properties together define the desirable properties for database transactions. And it provides a set of guarantees which application developers can assume and do not have to worry about in their application. So these guarantees are provided by the database itself. So let's look at each of these properties one by one. A for atomicity. A transaction is either successful in its entirety or not performed at all. In typical database systems, atomicity is guaranteed by transaction semantics. So in the database, you can define when a transaction begins, and then define a set of operations that belong in a transaction, and then define when the transaction ends. A transaction that completes successfully is committed to the database, and its effect will always be in the database. A transaction that is aborted or terminated midway before we reach the commit point has to be rolled back. Therefore, atomicity guarantees that a transaction happens entirely or not performed at all. This is a property that databases have to guarantee for applications if they require it. Next, we look at consistency. The main idea behind consistency is that the database will always remain in a consistent state before and after a transaction is executed. Consistency could mean a number of things. In the typical database world, this means that the data is accurate in modeling the real world and all of the constraints are followed. Consider a bank. Suppose a user is going to withdraw $100 from the bank and issues a transaction to withdraw $100. Now, depending on how the bank has set up the database for the bank and the rules that the bank has for accounts, it can conduct the transaction. But if there is a rule that says that balances in the accounts must never ever be in negative form, then this transaction should not happen. It should roll back because the result of this transaction leaves the database in an inconsistent state where the balance is a negative number. Another factor about consistency is that the consistency model that you use, especially when you have multiple transactions that occur simultaneously, the model that you use for consistency will also determine how soon new data to the database is visible to other nodes and clients. Next, we look at isolation. In isolation, transactions should execute as if they're running by themselves. Now imagine the same scenario where we have the bank database and we have a customer that's withdrawing $100. If simultaneously another customer were to withdraw $100, they should not interfere with each other. In fact, in this model, there needs to be strict isolation. So one transaction must be ordered before the other. Otherwise, it might be possible for both the users to withdraw $100 simultaneously, but the balance was only deducted once. So any transactions that are happening concurrently to the accounts must not interfere with each other in this example. This requires concurrency control protocols, and that's kind of beyond the scope of this video, but there are different types of concurrency control protocols and they have an associated performance. Finally, durability. The actions performed in the transaction should persist after the transaction is committed to the database. So if a user were to withdraw $100 from the database, that action should persist in the database. If you were to check the balance in the future, anytime in the future, the effect of that $100 withdrawal must always be present in the database. Durability is an issue in certain databases because databases are designed to buffer data in memory and they have to persist these to disk in a recoverable manner. If the database were to crash, then any transactions that were marked as committed must persist in the database. One solution that many database products use is the concept of write-ahead logging. So before a transaction is committed, the actual action that is going to be performed by the transaction is stored persistently in some kind of log on durable storage.